Hey guys, today we are calculating variance and standard deviation. And this is more measures of dispersions. So the first thing to talk about is variance. Variance is denoted as this, it looks like a zero with a little line coming off of it squared. And the way it's pronounced is sigma squared. And the equation, the formula for sigma squared for variance, what we do is we take each data value, we subtract x bar, which is the mean, and then we square it, adding the next data value, subtracting the mean, and we square it. And every single data value, we add them up, and we are taking the last data value, subtracting the mean, and then squaring it, dividing the whole thing by the number of data values. There are 10 data values to divide by 10. All right, cool. Let's do an example. Pause that, and then let's do an example, and you can write this example down. The distance in miles that you walked last week are 4, 3, 3, 5, 2, 2, and 4, and we're finding the variance. So that means on Monday you walked 4, on Tuesday 3 miles, on Wednesday 3 miles, Thursday 5 miles, Friday 2 miles, Saturday 2 miles, and Sunday 4 miles. So to find the variance, remember we need the mean. So that's the first thing I had us calculate. So we're adding all 7 numbers up. We get 23. Dividing by 7, we get approximately 3.29. So that's our first step for finding the variance. Then what we need to do is each data set has to be subtracted by this 3.29 because that's my mean. And then we'll square it after the fact, but we subtract first. So we have all 7. Here they are. So my first one is 4. 4 minus 3.29 in parentheses squared plus 3 minus 3.29 squared plus 3 minus 3.29 squared plus 5 minus 3.29 squared plus 2 minus 3.29 squared plus 2 minus 3.29 squared plus 4 minus 3.29 squared all over 7. Then we do some math. We subtract each one first before we square it. 4 minus 3.29 is 0.71 squared plus 3 minus 3.29 is negative 0.29 squared. Again, negative 0.29 squared. I know it's hard to see, that's why you got to listen. Plus, when I subtract 5 minus 3.29, I get 1.71 squared. Then when I do 2 minus 3.29, that is negative 1.29 squared plus another negative 1.29 squared plus lastly 4 minus 3.29 is 0.71 squared, all divided by, again, 7. Get this down. Now I've got to square each one. So I square 0.71, I square 0.29, I negative 0.29, I do that again. 171, negative 129, negative 129, and 71. And I should get 7 values. After I square them, they should all be positive because anything squared is going to give me a positive value. So I have 0.50 plus 0.08 plus 0.08 plus 2.92 plus 1.66 plus another 1.66 plus 0.50 again, all divided by 7. And I get 7.4 divided by 7 is 1.06. So the variance of the miles that you walked last week is 1.06. So that is all around each other. Remember, this is how spread the data is with dispersion. All right, cool. Let's go to standard deviation. So much easier now that we have the variance. Let's talk about standard deviation. It's denoted just sigma. So that like 0 with the little hook, it's kind of like a weird 6. That's called sigma. And what sigma is, it's the square root of the variance. So we have x1 minus x bar squared plus x2 minus x bar squared plus ... all of those data values plus the last data value x to the xn minus x bar squared all over n, and you have the square root of all of that. So this is your variance formula that we just looked at right here. Variance sigma squared. How do we undo a square? We take the square root of each side, and that's why we have sigma equaling the square root of all of that. So again, same example. The distance in miles that you walked last week are 4, 3, 3, 5, 2, 2, and 4. Find the standard deviation this time. Well, we already did our variance. We got 1.06. So this is easy. We just take the square root of 1.06 and we get about 1.03. So the standard deviation is 1.03 for the miles that you walked. And then just different levels of dispersion. We're not actually doing the statistics of what these mean in detail. We're just doing the math end of it so that later in school you can do much better with this and maybe your job. Okay.